In this class we're going to look at cookies. Cookies are short strings of text that can be left behind by a server on the user's machine. When the user returns to the website, pages can have access to that cookie that was left behind at an earlier stage. However, before we start dealing with cookies, we have to understand how it is that JavaScript deals with text. For the most part, text is treated in JavaScript as if it was an array of characters. Hopefully you're familiar with arrays from your previous programming courses. Arrays in JavaScript are fairly straightforward, and we can see how one is declared here. Here we have var, myNumbers, new, array. And then in brackets we've listed the elements of the array one after the other. So here we're not only declaring the array, we're actually populating it as well. Now invariably the first item of an array is item 0, and invariably this causes confusion for some students. Because this means that if you have 20 items in an array, the last item is item number 19, not 20. Individual elements of an array can be referenced by using square brackets and the index into the array. So here we're saying x is assigned myNumbers 2 plus myNumbers 6. And so x will then have the value of 92 plus 11, which is 103. JavaScript supports one-dimensional arrays. Now arrays can usually hold any type, so you could have an array of integers or an array of strings, for example. Now, as we've seen in the past, JavaScript isn't very strict when it comes to typing. So you could probably be a bit more flexible than you could be with other programming languages. But using that flexibility isn't always a good idea. So maybe you need to be more strict with yourself than JavaScript is. Now, very often in programs, you want to count through the elements of an array from the beginning to the end. There's actually a very handy function in JavaScript to do just that. It's a special type of for loop. It's the for in loop. So here we could say for var x in myNumbers, and then we say document write myNumbers x plus br slash. So it's going to go on to a new line. But what this is going to do, it's going to step through from the beginning of the array to the end of the array using the variable x as a counter. So this is a very useful shorthand for what would be several lines of code ordinarily. The .length method will return the length of an array. So myNumbers.length returns the number of elements in the array. Now this is not the same as the number of the last one. If you have 20 elements in an array, the first one is number 0 and the last one is item number 19. The join method takes all of the items in the array and puts them into a single string. So myNumbers.join returns one string with all of the elements in the array separated by commas. That doesn't have to be a comma if you don't want. You can actually pass in the separator as a parameter. This is very useful if you're working with arrays in JavaScript. JavaScript is often quite difficult to debug because more likely than not you're not working with an advanced debugging tool. You just have the notepad in front of you and you open it up in a browser and it'll work or not work. So if you're working with arrays, that's particularly troublesome. However, this join method is very handy because it means you can output to the screen the entire contents of an array and see what it looks like. The slice method will return a subarray from an array. So myNumbers.slice start stop will return the subarray with the first element at start and then the last element is at stop -1 as it happens. You'd expect stop to be the last element, but this range isn't inclusive. This allows the end point to be the starting point of the rest of the array. So myNumbers.slice to 5 will evaluate to a smaller array that has the contents of 2, 3 and 4 in it, not 5. So this will be an array with 3 elements, the first one 92, the next one 1687, and then the last one will be 13. Now splice allows you to remove a part of the array. So myNumbers.splice start n alters the array by starting with element start and removing n elements. So myNumbers.splice to 3 will go to element number 2 and then remove 3 items from the array. Now slice and splice actually behave quite similarly, but they illustrate a very important distinction between different kinds of methods in JavaScript. JavaScript doesn't make the distinction between functions, which merely evaluate to things, and procedures which actually alter elements. So you have to be careful, because in JavaScript, functions and procedures aren't very well distinguished. Another handy way of accessing arrays is using push and pop. A stack is a special kind of array that can only be accessed in 2 different ways. You can push something onto the top of the stack, or you can pop something off the top of the stack. But things can only go on at one end. It's meant to resemble a stack of plates like in a restaurant, and you can put one on top of another. So you're only ever working with the top of a stack. myNumbers.push25 will insert 25 at the top of the array. So 25 will now be the last element in the array. Pop here, in addition to taking the element off the top of the array, also evaluates the item that was popped. Cookies are small strings of text that are left behind by a web server on a user's machine. Now, in the early days, cookies got a bit of a bad rep because they represented a bit of a security threat, because people were using cookies in slightly unethical ways, and websites ended up gathering information about users without their permission. The situation has improved somewhat now. Browsers are a bit more sophisticated nowadays, and so this particular problem doesn't arise. So the server leaves this little nugget of information behind on the user's machine, and then if the user comes back to the website again, the website is able to recognize that this is a visitor who's been there before. This is how sites like Amazon, for example, are able to greet you by name when you arrive. And any sites that offer some sort of personalization use cookies. Cookies also perform a very important technical function. It's possible for JavaScript code in a page to declare a variable and use that variable at will. However, when the user goes to a separate page, there's no way for the contents of variables to be preserved from one page to another. So JavaScript in one page can't use variables declared in another. This is where cookies come into play. Cookies can also be used as a variable store, so that the contents of variables can be passed from one page to another. So if you have a multi-page process, let's say you're ordering something online, you have your shopping basket, and then you enter your credit card details, and then you enter your address, and this happens across several different pages, you need some way of making the connection between those pages. And cookies can be used for that. Now, there's really no mystery about cookies. Structurally, they're actually very, very simple. A cookie is just a string. Now, the contents of the string are in a particular format to make it easier to get at them. Let's look first at how a cookie might be created. Here we say document.cookie equals, and then in double quotes we have name equals Martin. Then this will create the cookie name equals Martin. If there is an existing cookie from this website there already, then name equals Martin will be appended to the end of the existing cookie, and each item in the cookie is separated by semicolon. So next up we say document.cookie equals phone equals 087 999 1234. So now the cookie will have name equals Martin, semicolon, phone equals 087 999 1234. And then there'll be a semicolon at the end to mark the end of the cookie. Because the semicolon is used to delimit the items in the cookie, you can't actually have semicolons inside your cookie items, nor can you have commas or spaces. Now, reading a cookie is a bit complicated because it's just a big string, and we have to extract the information we want out of that string using some JavaScript code. We can assign the contents of a cookie to a variable fairly easily. Here we're saying strCookie is assigned document.cookie. So now strCookie will hold all of the cookies available to this page, and they'll be in a long string delimited by semicolons. The next thing we have to do now is extract the actual cookie we want from this long string. Let's say we want to get the phone number. Well, the first thing we do is we look for the location of the string phone equals in the cookie string. When we find phone equals, we know the number we're looking for then is immediately after that in this long string. So here we're saying int location equals string cookie dot index of, and then the parameter to the index of is phone equals. So this will give us the starting point of the substring phone equals in the larger string. And we've put that into the variable called int location. But this only tells us where the phone equals string starts. The actual phone number doesn't start there. It starts further in. In fact, because phone equals is 1, 2, 3, 4, 5, 6 characters long, the number we're looking for actually starts 6 characters after this. So we'd say int start is assigned int location plus 6. So now we have the starting point of the phone number we're looking for inside in the variable int start. What we need to figure out now is where this phone number cookie ends. Now, if we were absolutely confident that it was a 10-digit phone number, we could probably just get to work straight away and extract that out of the string. But we can't be so sure. And even if we were confident about the phone number, that's not a technique we could use generally. So what we need to figure out now is where the phone number ends. And this is where those semicolons come into play. Because each cookie in this long string is separated from the previous cookie by a semicolon, we can find the end of the phone number by looking for the next occurrence of a semicolon. So we use the index of again to search the string for a semicolon. But we only start looking for the semicolon after the point in the string where we know that the phone number begins. The very next semicolon will then have the end position of the phone number. So here we say int end equals string cookie dot index of, and then we look for semicolon, but we only start looking for it at position int start. So now int end will hold the location of the semicolon that comes after the phone number cookie. So now we know where the phone number starts, and now we know where the semicolon after it is. So now we know the exact position of the beginning and end of the phone number in this long string. So to extract the phone number from the string, we say strph is assigned strcookie.slice, and we have int start and int end. Now you might be tempted here to say int end -1, but actually the way slice works, the end parameter isn't included anyway. That's actually the start of the remainder of the string. So this works out just fine. Now I mentioned that in the early days there were some privacy and security issues with cookies. Suppose you went along to a website and you willingly gave that website some information about yourself, and for convenience the website stored that information in a cookie on your machine. That was fine, and the next time you came back to the website, that information that was stored in the cookie would be available to the web pages. Very handy. However, what was happening was that totally unconnected websites would go on a trawl through your cookies looking for information that might be useful or information that they could exploit. However, the situation is improved now because browsers will only reveal the contents of a cookie to the website that created it. So a cookie can only be seen by the web page that created it or other web pages in the same folder, or pages that are in a subfolder of the directory that created it. So only the page itself, its siblings and its children can access the cookie. So it makes sense that the page that wrote the cookie should be able to see it. It also makes sense that the other pages in the same directory should be able to see it, because of course one of the reasons you would want to use cookies is to pass information between pages. Now we saw that there were two main reasons for having cookies. You want to preserve information from one page to the next on a website, or you want to keep information until the next time that the visitor comes to the website. Now to pass information from page to page, the information only has to last as long as the session, and the cookie will expire after the session. So once the transactions have been completed, the cookie will be deleted. Now if you want the cookie to be available the next time the visitor comes to the website, it's going to have to last longer than that. You have to set an expiry date. The expiry date is the last day on which the cookie will be available. Now this is specified using the year, month and day. It's more typical to have a cookie expire in, say, 3 months from now or 6 months from now. So that involves some calculations with the current date and the number of days you want it to last. Let's look at this code here to set the expiry date of a particular cookie. This cookie here will expire in 2007 on the 6th month. Now in JavaScript, the month is specified with January as being month 0, not month 1. So that often causes some confusion. So month 6 is in fact July, not June. So we create a new date object by saying new date 2007-6-20, and we assign that object to the variable theDate. We have theDate here instead of date because of course date is already used and it's reserved. Now the date must be stored in the cookie in a specific format. This is quite a long-winded format actually, and typing that character by character would actually be a lot of trouble. But we have a method that can convert the date object to this particular format, which is in universal time. So we have theDate.toUtcString, open bracket, close bracket. So this doesn't take any parameters, it just operates on the variable the date. So now the date is actually in universal time, which is a longer format. You could, if you wanted, actually output the date at this point just to see what it looks like. Now we're going to add a name cookie So we say document.cookie equals quote name equals Martin semicolon expires equals double quotes, and then we're going to append onto the end of that the date. So this now has written the cookie name given it the value Martin, and has also associated with that the expiry date. And so after the 20th of July 2007, this name cookie will no longer be available.